All right, in this next video, we are going to continue reviewing for your Module 3 test. So, what I'm going to be doing here is finding a polynomial function of degree 3. What that means is the highest exponent I'm going to have after I multiply everything together will be 3. The zeros that it gives me are -1, +2, and -8. So the first thing I am going to do is turn those zeros into the factors that they came from. So the -1 is the first zero that I'm talking about. If -1 is a zero, it came from the factor of x plus 1. The +2 0 came from x minus 2, and the -8 0 came from x plus 8. And then I am going to multiply all three of these factors together, starting with the first two factors. So x times x gives me x squared. My outside, x times -2, gives me -2x. My inside, +1 times x gives me +1x. And then my last, +1 times -2 gives me -2. Now I notice I have like terms in the middle there, which means I can put those together. So now I've got x squared minus 1x minus 2. And I'll drop down that last factor of x plus 8. And then I will multiply here. The first thing I'm going to do is distribute this x squared to both terms of the second factor. So x squared times x gives me x to the third. Then I've got x squared times +8, which gives me +8x squared. Then I'll move down the line and I'll distribute this -x to both of the terms in the second factor. So -x times +x gives me -x squared. -x times +8 gives me -8x. And then I will move down to the -2 and distribute it to both terms of the second factor. So -2 times x gives me -2x, and -2 times +8 gives me -16. So now when I combine like terms, I can put my squareds together and I can put my x's together. So I will have x to the third, 8x squared minus 1x squared, so now I have +7x squared. -8x minus 2x gives me -10x, and then bring down the -16. So there is your factor, or excuse me, your polynomial function of degree 3 with the given zeros. Now, you'll notice when you were typing in the answer, it just asked for the squareds. So you just have to put in that 7 coefficient there. All right, on this next one, again, we're going to be finding a polynomial function with these given zeros, the square root of 5, negative square root of 5, and 4. So, just like the last one, I'm going to turn these into their factors. So, if the square root of 5 is a 0, it came from x minus the square root of 5. If negative square root of 5 is a 0, it came from x plus the square root of 5. And the last 0 is 4, so it came from x minus 4. Now, I'm going to multiply these three factors together, and I'm starting with the factors that have the square roots in them because they are conjugate pairs, which means when I multiply them together, They're actually going to clean each other up. So let's look at multiplying. X times x gives me x squared. X times positive square root of 5 is positive x square root of 5. The inner is just going to be the opposite of that, negative x square root of 5. And then my last negative square root of 5 times positive square root of 5 gives me negative square root of 25. Okay, now these middle two terms are like terms, and one's positive and one's negative of the same thing, so they just cancel each other out. So I am left with that x squared minus this square root of 25, and the square root of 25 is just 5. So I am just left with x squared minus 5, and then bring down your other factor, which is the x minus 4, and multiply those together. So x squared times x gives me x to the third. My outside, x squared times negative 4 is negative 4 x squared. My inside is a negative 5x. And then my last negative 5 times negative 4 is positive 20, which would be that D option. All right, on this next question, we are going to find the missing zeros of what this polynomial function would be coming from. And remember, the zeros that come in your pairs are i's and square roots. So you'll notice that the zeros that are given are negative I and 12 minus the square root of 13. What that means is if negative I is a 0, then so is positive I. If 12 minus the square root of 13 is a 0, then so is 12 plus the square root of 13. So your answers are those two missing zeros. All right, on this next one, we are going to find any missing zeros and then find the polynomial function that they would turn into. So the zeros that it gives me are negative 3i and 5. Well, if negative 3i is a 0, then so is positive 3i. So those are going to be the three zeros that I have. So let's turn those into the three factors that they came from. So negative 3i would come from x plus 3i, 3i would come from x minus 3i, and 5 comes from x minus 5. And then I'm going to multiply the three factors together, and again starting with the conjugate pairs because they will clean each other up. So my first here, x times x gives me x squared. My outside would give me negative 3xi. The inside is going to be the opposite of that, negative 3xi, and then my last 3i times negative 3i gives me negative 9i squared. So when I put those like terms together in the middle, they just cancel. So now I have x squared. Also, this I squared, anytime you see I squared, it is equal to negative 1. So you have negative 9 times negative 1, which gives you positive 9. So you're left with x squared plus 9, and then you'll drop down the other x minus 5 And now we'll multiply these two factors together. X squared times x gives me x to the third. My outside, x squared times negative 5 gives me negative 5 x squared. My inner, positive 9x, and my last 9 times negative 5 gives me negative 45. All right, on this one, it gives us the polynomial function, and 1 0 is given. The 0 that is given is 8i. It wants me to find the remaining zeros. Well, first of all, if 8i is a 0, then so is negative 8i. And also, remember that the other zeros could be seen on a graph because zeros, the real zeros are going to be x-intercepts. So let's put this function, x to the fourth plus 55x squared minus 576 in our y equals of our calculator. So I'm going to go to my y equals, put in my function, x to the fourth plus 55x squared minus 576. And let's graph that. So it looks as if there's x-intercepts at positive 3 and negative 3. I can double check that by looking at the table, second table. At those x's, the y coordinates should be 0. You'll notice that there's the positive 3, its y is 0. Now let's look at negative 3. And its y is also 0. So what that tells me is that the other two zeros besides the 8i, we're going to be the negative 8i and negative 3 and positive 3.